Okay, so good day everyone. So for this video, we will be discussing case 4 of integration by partial fraction decomposition. So for this case, we have repeated quadratic factors. Okay, so let's take a look at this example. So integrate x cubed minus 2x squared plus 1 dx all over x squared minus 2x plus 5 squared. Okay, so as you can see, we have here a denominator containing a quadratic factor, okay, repeated twice. Okay, uh, so in this problem, so we will decompose this into partial fractions. Okay, so using still the similar steps, so by partial fraction decomposition, so we'll have x cubed minus 2x squared plus 1 all over x squared minus 2x plus 5. Okay, so resolving that into partial fractions, so the partial fractions will contain this is squared, so the denominator will contain the factors, okay, of the denominator. So first is we will have a fraction with a denominator of x squared minus 2x plus 5, and then another one with a denominator of x squared minus 2x plus 5 squared. So the first one, we have x squared minus 2x plus 5 plus. Okay, so for the second fraction, so we will have a denominator of x squared minus 2x plus 5 squared. Okay, and similar in case 3. Okay, so if we have a quadratic denominator, so its numerator should be linear. Okay, and since we are expecting later on that we will have a we will integrate using the natural logarithm, then the x term in the linear term will be the derivative of the denominator. So instead of writing ax plus b, so we will write x as the derivative of the denominator. So we will have a times, so instead of writing x, so write the derivative of the denominator. So derivative of x squared minus 2x plus 5, so that is 2x minus 2. Okay, plus b. Okay, so in this form, this is still linear. Okay, plus, so similar with the first term, so we'll have c times 2x minus 2 plus d. Okay, so next, cross multiply this, okay, the denominator, so cross multiply for each term. So we'll have x cubed minus 2x squared plus 1 is equal to, so we'll have a times 2x minus 2 plus b multiplied by, so if we multiply this, so it will cancel out 1, x squared minus 2x plus 5, so therefore what will remain is x squared minus 2x plus 5. Okay, and then if we cross multiply this on the second term, so it will cancel out all of the denominator, so what will remain is plus c times 2x minus 2, okay, plus d. Okay, so the next is we'll distribute this, so we will have x cubed minus 2x squared plus 1 is equal to a times 2x minus 2 times x squared minus 2x plus 5, okay, plus b times x squared minus 2x plus 5, okay, plus c times 2x minus 2, and then plus d. Okay, so the next is expand this, so we can do this on another sheet of paper, okay, so that will avoid writing so much. So So multiplying this, so 2x minus 2 multiplied by x squared minus 2x plus 5, so that is equal to, so 2x times x squared, that is 2x cubed, 2x times negative 2x, so that is minus 4x squared, 2x times 5, so that is plus 10x, negative 2 times x squared, so minus 2x squared, negative 2 times negative 2x, so that is plus 4x, negative 2 times 5, that is minus 10. So simplifying, this is 2x cubed minus negative 4 minus 2, that is minus 6x squared, 10x plus 4x, that is plus 14x, and then minus 10. Okay, so therefore this is equal to this. Okay, so rewriting, x cubed minus 2x squared plus 1 is equal to a times 2x cubed minus 6x squared plus 14x minus 10. Okay, plus b times x squared minus 2x plus 5, okay, plus c times 2x minus 2, okay, and then plus d. Okay, so next is equate coefficients of similar terms. Okay, first is for x cubed. So for these steps, we're gonna be solving now the constants a, b, c, and d. So for x cubed, on the left side we have 1 is equal to, on the right side we have a. If we distribute a, so this will become 2a x cubed. So the coefficient of x cubed is 2a, and then on the other terms no x cubed, so therefore can solve for a. So 1 is equal to 2a, therefore dividing both sides by 2, so we'll have a is equal to 1/2. Okay, so next is for x squared. On the left side we have negative 2 is equal to x squared, so negative 6a here plus b, and then no x squared on c and d. So therefore, substituting, since we already know that a is equal to 1/2, so therefore we'll have negative 2 is equal to negative 6 times 1/2 plus b. So negative 2 is equal to 6 times 1/2, so that is negative 3 plus b. So that's transposing 3 on the other side, it will become positive 3 minus 2, so b is equal to positive 1. Next is coefficients of x. On the left side, no x, so therefore 0 is equal to, on the right side we have a times 14, so 14a, and then minus 2b plus 2c. Okay, then since we know that a is equal to 1/2 and b is equal to 1, so therefore 0 is equal to 14 times 1/2 minus 2 times 1 plus 2c. So we will have 0 is equal to, this is 7 minus 2 plus 2c. Okay, so transposing on the other side, so we'll have 7 minus 2, so that is 5. Transposing on the other side, that's negative 5. So therefore, negative 5 is equal to 2c. So dividing both sides with 2, so we can come up with c is equal to negative 5 over 2. Okay, so for last one, coefficients of the constants, x raised to 0. So on the left side, constant is 1 is equal to negative 10a, and then plus 5b minus 2c, and then constant d. Okay, so since we know that a is equal to 1/2, b is equal to 1, and c is equal to negative 5/2, so therefore 1 is equal to negative 10 times 1/2 plus b of 1, so 5 times 1, minus 2 times c is negative 5/2, okay, plus d. So therefore we'll have 1 is equal to, this is negative 5 plus 5, negative 2 times negative 5/2, so that is plus 5, okay, plus d. So we'll have negative 5 plus 5, so transposing 5 on the other side, so it will become 1 minus 5, so therefore d is equal to negative 4. Okay, so in this partial fraction, a is equal to 1/2, b is equal to, so this b is equal to 1, okay, c is equal to negative 5/2, and d is equal to negative 4. Okay, so we will replace that, we will replace the unknowns with the values that we have solved. So rewriting the integral, so again the integral was integral of x cubed minus 2x squared plus 1, okay, sorry, okay, so rewriting the integral, so the integral of x cubed minus 2x squared plus 1 all over x squared minus 2x plus 5 squared, okay, dx, so is equal to integral of, so the partial fractions, so replacing it with this, so it will become so ax plus b, so we have 1/2 times 2x minus 1 plus b of 1 all over x squared minus 2x plus 5, okay, plus for the second term, c is equal to negative 5/2, so negative 5/2 times 2x minus 2, sorry, this is 2x minus 2, okay, minus d, so we have negative 4 over x squared minus 2x plus 5 squared, okay, dx. Okay, so in integrating that, so we will distribute the integral sign in dx, and also we will separate this fraction, so the first term will be consist of this, so the 1/2 2x minus 2 over x squared minus 2x plus 5, and then the other one is 1 over x squared minus 2x plus 5. Okay, so basically we will separate this, so we'll separate it first, so integral of, so we'll have 1/2 times 2x minus 2 over x squared minus 2x plus 5 plus 1 over x squared minus 2x plus 5, okay, plus for the second term, we will separate the second term, plus, so negative 5/2 times 2x minus 2, okay, over x squared minus 2x plus 5 squared, and then the last one is plus negative 4, sorry, negative 4 over x squared minus 2x plus 5 squared. Okay, and then dx. Okay, so if we distribute the integral sign and then the dx, so let's move the equal sign over here so that will fit. So distributing here, so we have a numerical coefficient of 1/2, so we can write that outside the integral sign. So 1/2 integral of, so what will remain will be 2x minus 2 dx over x squared minus 2x plus 5. Okay, plus we have integral of sorry, integral of, so dx over x squared minus 2x plus 5. Okay, on the third term, so we have here a coefficient of negative 5/2, so we can take that out of the integral sign. So negative 5/2 integral of 2x minus 2 dx over x squared minus 2x plus 5 squared. Okay, and then minus, so we have a numerical coefficient of 4, so minus 4 integral of dx over x squared minus 2x plus 5 squared. Okay, so we'll now integrate each term. So the first term, we can integrate that using natural logarithm. The second term, we can integrate that using inverse trigonometric function. For the third term, we can integrate this using the general power formula. This one, it's the most difficult to integrate, but for case 4, so usually we can use here trigonometric substitution. Okay, so we write this first into a form where it can be easily integrated. So for the first term, so the numerator is the complete derivative of the denominator, so no need to rewrite anything. So 1/2 integral of 2x minus 2 dx over x squared minus 2x plus 5. Okay, plus. In the second term, on the other hand, so since we will be using inverse trigonometric function for this, so we will transform the denominator into a form where we can apply the inverse trigonometric function. So particularly, we can use here the arctangent. So it should be in the form of integral of du over a squared plus u squared. Okay, so as you can see, we have here x squared minus 2x plus 5. So we can decompose that into finding first the third term to complete the square. So we have what is that? X squared minus 2x plus 5. So it's the third term for this to be a perfect square trinomial is 1. So x squared minus 2x plus 1, and then 5 minus 1, that is plus 4. Okay, so it will become x minus 1 squared plus 4 squared, that is 2 squared. Okay, so x squared minus 2x plus 5, that is equal to x minus 1 squared plus 2 squared. Okay, numerator we have dx minus, so this is simply general power formula. So we can write the denominator, we can transfer it into the numerator. So 5 halves integral of x squared minus 2x plus 5 raised to negative 2 times 2x minus 2 dx. Okay, so the last term, so we have the last term is minus 4 integral of, so to apply later on the trigonometric substitution, so you can also copy this form. Okay, so what we did in x squared minus 2x plus 5, so we can rewrite this as dx over x minus 1 squared, okay, plus 2 squared then squared. Okay, so integrating, so the first term can be easily integrated using the general power formula, the natural logarithm, because the numerator is the complete differential of the denominator. Here we can use arctangent, inverse trigonometric function. So as I've said here earlier, the general power formula. So the longest will be this last term, so because we're going to be using trigonometric substitution. So integrating first the things that the terms that we can already integrate. So this is 1/2 ln of x squared minus 2x plus 5. Okay, and then this one plus, so using the inverse trigonometric function, arctangent, so this is 1 over a arctan of u over a. So our u is x minus 1, its du is dx, so we don't need to add any more coefficients. And then this is a is equal to 2, so therefore we will have 1 over a, so 1/2 arctan of u over a, so u is x minus 1 over 2. Okay, so minus this one, so 5 halves times, so power formula, so we have here our u is x squared minus 2x plus 5, our n is equal to negative 2, our du is the complete differential of this, so therefore we can apply directly the general power formula. So times, this will be x squared minus 2x plus 5 raised to negative 2 plus 1 over negative 2 plus 1. Okay, so last term is, you can integrate this using trigonometric substitution, so we'll do it in a separate sheet of paper. So we will integrate dx over x minus 1 squared plus 2 squared squared. Okay, so we can use, since it's in the form of x squared plus a squared, so we can use tangent theta. So let x minus 1 is equal to a tangent theta, so our a is 2, so 2 tangent of theta. So differentiating, so our dx is equal to, so derivative of 1 is constant, so on the left side it will only be dx, so derivative of tangent theta is secant squared theta, so therefore this will be 2 secant squared theta d theta. Okay, so substituting that, so we'll have integral of, so in the numerator dx, so dx is equal to 2 secant squared theta d theta. the denominator. So x minus 1 is equal to 2 tangent theta. So this will become, so if we square this, so this will become 4 tangent squared theta. Plus 2 squared is obviously also 4 10 squared. Okay, so we can factor out 4 to integral of 2 secant squared theta d theta all over 4. So what will remain is tangent squared theta plus 1. Then both of them are squared. Okay, so we'll have 2 secant squared theta d theta, and then 4 squared, that is 16, and then tangent squared theta plus 1, that is secant squared theta, and then also squared, so therefore we'll have secant to the 4th theta d theta. Okay, so we have 2 over 16, that is 1/8. So we can write that outside the integral sign. Integral of secant squared theta over secant to the 4th theta, that is, sorry, there's no d theta there. So secant squared theta over secant to the 4th theta, that is 1 over secant squared theta, right? So d theta over secant squared theta. So but we know that secant squared theta is equal to the 1 over secant squared theta, that is equal to cosine squared theta. Okay, so next is integrating. So integrate cosine squared theta d theta. So that is case 4 of trigonometric transformation. So we can substitute cosine squared theta is equal to 1/2 times 1 plus cosine 2 theta. So we'll have 1/8 integral of 1/2 times 1 plus cosine 2 theta, okay, d theta. Okay, so let's distribute 1/2 and 1/8. So we'll have 1 over 16 integral of d theta plus also 1 over 16 integral of cosine 2 theta d theta. Okay, so integral of cosine is sine, no, but notice we have here 2 theta, therefore our d theta here should be 2 d theta. So there's a missing 1/2, so plus missing 2, so 1 over 16 integral of cosine 2 theta. Okay, the differential part should be 2d theta. So multiply here 1/2. So therefore this will become 1 over 16 theta plus 1 over 32. Integral of cosine is sine 2 theta. Okay, so from our substitution, so we have x minus 1 is equal to 2 tangent of theta. So x minus 1 is equal to 2 tangent of theta. So dividing both sides by 2, so we'll have x minus 1 over 2 is equal to tangent of theta. So therefore our theta is equal to arctangent of x minus 1 over 2. Okay, so for here, so to solve for sine 2 theta, so we will construct the triangle. Okay, so if this is our theta, so from here, so tangent theta is equal to opposite over adjacent. So therefore the opposite side is x minus 1, adjacent side is 2. Okay, by the Pythagorean theorem, this will be square root of x minus 1 squared plus 2 squared. Okay, so we have sine 2 theta. So sine 2 theta is equal to 2 from the identities. So 2 sine theta cosine theta. So sine theta is opposite over hypotenuse. So its opposite is x minus 1. Hypotenuse is this, square root of x minus 1 squared plus 2 squared, or we can rewrite this as square root of x squared minus 2x plus 5. Okay, so this one. So this will become x minus 1 over square root of x squared minus 2x plus 5. Multiplied by cosine theta is adjacent over hypotenuse. So adjacent side is 2 over, still the hypotenuse is square root of x squared minus 2x plus 5. So therefore, sine 2 theta is equal to, so 2 times 2, we have 4 times x minus 1. So multiplying this 2 will remove the square root. So it will become x squared minus 2x plus 5. Okay, so therefore, 1 over 16 theta is arctan of x minus 1 over 2. Okay, plus 1 over 32 times sine 2 theta is this. So 4 times x minus 1 over x squared minus 2x plus 5. Okay, so this is 1 over 16 arc tan of x minus 1 over 2 plus, so 4 over 32, that is 1/8. Okay, times x minus 1 over x squared minus 2x plus 5. Okay, so this is now therefore the equivalent of the integral of dx over so this is the integral of dx over x minus 1 squared plus 2 squared squared. Okay, so therefore we will replace this, okay, with this. Okay, so minus so where were we? So minus 4. Okay, so minus, so let's just write this here. So minus 4, then the integral of dx over this is 1 over 16 arctan of x minus 1 over 2 plus, we have 1/8 times x minus 1 over x squared minus 2x plus 5. Okay, since we finished integrating, so plus c. So as you can see, we have some similar terms. So we have the arctan and also this one later on. So let's just finish this first. So we have 1/2 ln of x squared minus 2x plus 5 plus 1/2 arctan of x minus 1 over 2 . And then this will become 5 halves, and then we have here negative 1, so plus 5 halves times 1 over, so this will become 1 over x squared minus 2x plus 5. Okay, so minus, so distributing 4, 1 over 16, so we'll have 4 over 16, so that's minus 1 over 4 arctan of x minus 1 over 2. Okay, and the last one, so distributing negative 4, so we'll have minus 1 half. Okay, times x minus 1 over x squared plus 2x plus 5, but we can rewrite 1 half in the numerator, negative 1 half in the numerator, so that it will be easier to add later on. So we have plus negative 1 half times x minus 1 over x squared minus 2x plus 5. Okay, so as you can see, we have here our similar terms. So arctan x minus 1 over 2, and then this one, the same denominator, so we can add the numerators. So earlier it's easier maybe to, if we have written this in the numerator. Okay, so similar with what we did here, so this will become 1 half ln of x squared minus 2x plus 5, so 1 half arctan of x minus 1 over 2 minus 1 fourth arctan of x minus 1 over 2, so 1 half minus 1 fourth, that is plus 1 fourth arctan of x minus 1 over 2. And here, since we have similar terms, we can add them, so plus, so we'll have a common denominator of x squared minus 2x plus 5, so we can add here, so 5 halves minus 1 half times x minus 1. Okay, plus c. Okay, so adding, so we'll have 1 half ln of x squared minus 2x plus 5 plus 1 fourth arctan of x minus 1 over 2, and then this will become plus so if you have distributed negative 1 half, so this will become 5 halves minus 1 half x plus 1 half, so we'll have negative 1 half x, and then 5 halves plus 1 half, so that's plus 3. Okay, over x squared minus 2x plus 5 plus c. Or say if you don't want a fraction in the numerator, so we can factor out negative 1 half. Okay, so if we factor out negative 1 half, it will become 1 half ln of x squared minus 2x plus 5 plus 1 fourth arctan of x minus 1 over 2. Okay, and then minus 1 half times, since we factor out negative 1 half, so what will remain here is x, and then 3 divided by negative 1 half, so that is minus 6 over x squared minus 2x plus 5. Okay, plus C. So rewriting it, our final answer will be 1 half ln of x squared minus 2x plus 5 plus 1 over 4 arctan of x minus 1 over 2 can have minus x minus 3 x minus 6 over 2 times x squared minus 2x plus 5 plus C. So as you can see, the process for this is very long. Okay, so the part here which makes it very long is the trigonometric substitution for the last term. Okay, but for the first 3 terms are actually fairly easy to integrate. So the first term can be integrated using natural logarithm, inverse trigonometric function, general power formula. So this one is the part where where the solution becomes very long. Okay, so but as long as you are good with trigonometric substitution, then you can still solve it. Okay, so thank you for watching. So if you have any questions, so just feel free to reach out. Okay, so thank you, and then good luck.